Hello student, I am Arnav Das. Today we discuss about the syndrome calculation and error detection. Lastly there are question we just passed through you that if at the receiver side the received signal is introduced with an error, that time how can receiver recognize there an error is introduced and which position the error is affected on there. And for this reason, their syndrome calculation is most effective one technique also by which you can or we can able to identify the is the received signal is coming as a correct form or not. Initially, we considered that the received signal is coming as a form of R and this is a n-bit data. It may be the form of R0, R1, R2 in such way Rn minus of 1. And the transmitted code word which is transmitted from the transmission section, it is defined by the V equal to V0, V1 up to Vn minus of 1 because the transmitted signal is coming for the n bit order form. So now our receiver side, their R0, R1, R2 up to Rn minus of 1 is received. Let E is the error which is introduced during the transmission. Therefore, obviously we can write down that R is the combination of transmitted signal or transmitted code word, that is the V plus with the error. So that is R is equal to V plus of E. Consider the parameter syndrome S for the received vector R and which is given as a form of S equal to R H transverse. This is not required to prove what is the way by which you got this one, but you have to memorize this one as a form of S equal to R H transverse, where S is defined the syndrome, R is defined as the form of received vector, H is defined for the parity generator matrix, and if you put the value of R, and already we know that the R is the summation of V plus of E. If you put this value in this position, that time the syndrome equation can be rewrite as a form of this, that is S equal to V plus of E into of H transverse, and which is as a form of S equal to V H transverse plus of E H transverse. Lastly, we also conclude that there V H transverse always should be equal to 0. So if VH transverse is equal to 0, then we can write down S is e to the e into of H transverse. That means this is a very important equation for the syndrome one. That means syndrome calculation. This is the most important equation. So by identifying the value of the S or syndrome, you can able to identify is there an error is introduced at the received signal or received code word or not. With also it can also informed at the receiver side which ultimate position the error is occurred. Let an example by which this one much easy for understand. For an LBC, syndrome is given as S1 is equal to this one, S2 and S3. Question is that you have to find for the option number A parity check matrix, that is the capital H. If you look as a clear view, that time S1, S2 or S3, here R is suffix starting from the 1 and the end at the maximum value of 7. That is R is starting from 1 and it is end at the position of R as a suffix 7. So you just apply this one for the reason of identification as a H transverse matrix. You already able to know that this is S equal to R H transverse. So from that particular information, you just apply the knowing data value. Here for the first cases, S1 is equal to R1 plus R2 plus R3 plus of R5. That means which term are not present in this case? That is R4 is not present, R6 is not present, R7 is not present. Again, I just repeat that 4, 6, 7 is not present in this position. So you just apply the same thing in here at the 4 position, at the 6 and 7 position. You just apply 0. So you make that particular column for the H transverse by using the first one equation for the S1. Now you check for the S of 2. For the S of 2, which terms are not present? Here S3 is missing and also S5 and S7. That means 3, 5, 7. So at the 3, 5, 7 position will be 0. Look that for the second column 0 is present for the 3, this is for the 5 and lastly this is for the 7. Same way for the S of 3, their missing terms are S2, S5 and 6. That is 2, 5, 5 and 6 position, the value will be 0. 2 and 5, 6 position, the value is 0 on there. So from here, the matrix which is got it, this is for the H transverse. So this is for the H transverse. If the H transverse is this one, then if you again transverse the matrix, then you can got the value for the H. That is, this column you just convert into the form of row. This is the row is given to you. That is, column for the H transverse is 1 1 1 0 1 0 0. You just convert into the form of row for the H. Same way for the second one column for the H transverse is 1 1 0 1 0 1 0. That one you just apply for the row for this one, that is the 1 1 0 1 0 1 0 on there. So you ultimately got the value for H or parity generator matrix, and that one is the first question for this one. Okay, for this one. Now the question is that you have to draw the encoder circuit for the question number B. How you can got this one? If you able to know the value of H, we know that H is written as a form of P is 2 of I, or as a P transverse, or it may be written as a form of I is 2 of P transverse. So you have to initially check that which form you got it in here. That is the P transverse of identity matrix or identity matrix with P transverse. In here, if you check this a this left hand side is indicate the parity as a transverse form, and the right hand side is indicate the identity matrix. So this side, this side is indicate the P transverse. So if you able to identify the P transverse, then transverse that particular matrix to get the value of P. Look that this is the P, where this row, that is the 1110 is write down as a form of column. Okay, again I just repeat that. You initially able to identify from this H matrix, this section is for P transverse. This is for the P transverse. And if you again transverse, that time this one will become for the P. This is for the P. This is for the P transverse. Now if you change, this row, that is the 1110, this is row, if you change as a form of column, so it will be 1110. Same way for the second row, that is the 1101, this can be write down as a column form for the P, that is the 1101. So in this way you can got the ultimate value for the P. Okay, and G is written as a form of IKP. So obviously if you got the value for the P, then from this section the remaining one for the G will be defined as a K, and this will be just as identity matrix 1. And due to the reason of P is coming as a total row of 4, so identity matrix for the G, it will be as a K cross K, that is the 4 cross 4 identity matrix we have to record to generate the G. Now here code, now here this is code is got it by using that particular value or formula. This is C is equal to D of G. So this is the D, and G is already you got it from the previous one. So from here you can identify the equation for the C1, for the C2, for the C3, for the C4 up to C7. So here C1 is equal to, you just this row you have to multiply it with the first column, that is C1 is, you just row is multiplied with the G as a first column. So what happened here, only the 1 is present for the first term, so only D1 is present on there, D2 is for only for the C2. In such a way you got this one. And lastly, if you again recall, then for the last column here where the 1 is present, at the D1 position, at the D3 and D4 position. So this equation is got it to you. And if you apply the mod to addition, then C7 you can able to got. By using this equation you can able to draw the encoded or encoder circuit diagram, and that one is this one. So for the first one figure, there what happened, C1 is directly equal to D1. So here C1 is directly connect with the D1. C2 is also as a equal to of D2. So this is directly connect with the D2, and for the D3 also only reason for the C3, and C4 is due to the reason of the D4 for the figure this one. This is the value, and for this reason this is coming as such. Now for the C5, this is the odd operation or mod 2 addition of D1, D2, D3. So D1, D2, D3. Look that for the C5, this is D1, D2 and D3 to get the output of C5. Same way for the C7 also, and this is the diagram for the encoder one for the given 7,4 LBC. 7 is the code word, because from the G we can able to know that n is equal to 7, and from the G or generator matrix we can know that their k equal to 4. So from this, if the 4 is the message signal, that time number of variation will be as a 2 to the power of 4, that is 16, and that one is starting from the 0, then 001 up to 111. For the individual message signal, that individual or different types of code word will be required or generate, and here the code word, by using this formula you can got this one. Okay, this one is the uh, for got it value for the code word. As I say, for the 10, for the 0010, the code word is 0010101. From the transmitter side it will be transmitted. Now at the transmitter side, the what is the code word generate, that particular code word position, how many number of one is present, on that counting you can able to find the code word Hamming weight. So first one not required to calculation, because here no one is present. Now for the second one, that is the for the message 0001, their code word is 0001011. So for this code word, their number of one is 3, so you can apply 3 for the Hamming code. Same way if you consider for this line, so what happened for the 1011, for this message the code word is coming as a value of 10110001. So how many number of one is there, that this is the 4, so this is 4 is coming on there. If you consider for the last one, their number of one is 7 due to the reason of message 1111. So here number of one for the code word is their total 7. So for this reason Hamming weight is 7 on there. So from this table, for individual, for this table individual code, what is the Hamming weight you can able to identify. And from this Hamming weight, which one is the minimum value? Obviously from this chart you can able to see that 3 is the minimum value, and for this reason, for this code, the d mean or minimum Hamming distance will be 3. So here it is written as, since the d mean is 3, so it can detect how many number of error, d mean minus of 1, that means 3 minus of 1. So 2-bit position for the message which is transferred as a code word form, if in the code word at the channel position, if the 2-bit position the error is occurred at the receiver section, it can able to identify, yes, there's some error is occurred, but how many number of error it can be correct, it will be depend on, as I said, t equal to d mean minus of 1 by of 2, that is 3 minus of 1 by 2. is equal to 1. That means if single bit position, if any error is occurred, then it can detect with also it can correct the error. That means it can identify what is the position where the error is effect, and this particular position you should have to alter the value. Okay, so that was the question number D for this example. This is for the example. Look that here this is question is that find the code word for all input sequence. You can do that one. And for the last one upper, this is given that how many error it can be detect and correct. So their detection will be as a maximum 2 because d min is there 3, and error correct is d min minus of 1 by of 2. That means 3 minus 1 by of 2, it will be equal to 1. So it can correct single bit error. As you say, now the receiver side, the 7-bit message is coming as a value of 10111011. Now the question is that is the signal is coming as a true form, or that no error is affected, or if there an error is affected, if it, then is it possible to identify where the error is present? So this is for the question number E for this example. You just check that one. What is the way by which you have to proceed? So from the starting of this lecture, I just told you that syndrome is equal to S and this is equal to R H transverse. So you already know the value for the R which is given to your question. That is at the receiver side you got this code word. Okay, that is the 10111011. At the receiver side you got this one, and you also know that by using the syndrome equation, that is the what is the value of H transverse, that is parity generator matrix in the transverse form. You already got it. So if you multiply as a matrix multiplication, that time what the result will become, the result will become as a 0 1 0. Why this is come as a 0 1 0? Easiest way I already told. Here the MSB side, from MSB side if you check the second bit position, here the 0 is present, so you just obsolete the second one row, and there another one is present, the LSB side third position. So this one, if those two side is obsolete, that time for the first column for this H matrix, H transverse matrix will be number of 1 1 2 2. So here mod 2 addition, the result will be 0. If you consider for the second one or the middle column for the H transverse, that time how many number of 1 is now there also 1 2 3. So here its value will become as a 3 for the middle one column. I just want to consider it, so 3. And for the last one column for the H transverse, if you omit this one line and this one line, so how many number of 1 1 2 1 2 3 4. This is total 4 number of 1 is present, so this is the even number. So here the value or resultant value will become as a value of 0 on there. Okay, so this is 0 1 0 is the result for the syndrome one. So from this, if you convert into the form of the binary 2 as a decimal value, again I just repeat that the syndrome result which you got it, you convert into the form of the binary 2 as a decimal value, so result will become as a 2. So 2 position the error is effect, and you should have to change that one. So 2 position is here, this is from the LSB side, 2 position is this one, uh, this one is the 2 position. So here what will be the value, it will be if change as a value of 0, that time the result or their error free result is come at the receiver side. So should at the receiver side to modify or to get the exact value, the second position you should be equal to 0. As you say, if the syndrome is coming as a each and every term as a 0, that means there no error is affected on there. So I think each and everyone can able to understand what is the requirement for the syndrome, and from the syndrome how can you detect and also identify the error for, and how many number of error can be uh, calculate, or it can be correct. You can also identify by using the d-mean. So today we just end in this position, and we will be again meet each and everyone will stay safe and good. Until I have to say as a good day and bye.